Before I continue, let's just peruse on the kinetic energy of a rolling body. So we have a body. This let's say this is an inclined plane, right? Can you see the body? This is an inclined plane, and we have a circular body rolling downwards. Now you know originally this body is like undergoing is under the influence of, let's say, two energy. This is everything mechanical, but it's undergoing translational energy and rotational energy. Yeah, our normal jam questions is undergoing rotational energy and translational energy, in the sense that they'll say the middle of this stuff is undergoing translational, while the edges are undergoing rotational. So since it is undergoing translational and rotational, to find the kinetic energy of this body moving, that means we need to find the kinetic energy of the translational energy and the kinetic energy of it rotating. So to find the total kinetic energy will now be the kinetic energy of the body itself rolling from the plane, from the inclined plane. So the kinetic energy for the trans the trans I'm talking about here is translation. So translational motion, not the so the translation here is trans the translation here, the kinetic energy for translation here is half mv squared. Our normal translational our normal formula for kinetic energy half mv squared. While for rotational, we are going to now consider the moment of inertia, and that will be half I w square. See. So this is the formula for the rotational kinetic energy, half I w square. So to get the total, the kinetic energy total will now be the kinetic energy of the trans plus the kinetic energy of the rotational. So that will be half mv squared, half mv squared plus half half I w squared. So if they ask you to find the kinetic energy of a body rolling, there's this question they used to ask. They will ask what is the ratio of they will ask what is the ratio of sphere. I think when you are solving questions on when you are solving past questions on if it's 101 before your exam, I'll solve past questions if you don't know. There's a question like that, there's a popular question like that, and the answer is maybe 2 or 5 or something. So there's a question like this, there's a question like that. But let's just solve the question in the slide before we start solving the UI past questions. You understand? UI past questions. All the questions I solve on this video, all the questions I solve on this channel are UI past questions. So don't go outside. Don't go outside the scope. It won't help you. You can know too much, but after knowing too much, still come down to knowing to pass your exam, not just knowing too much and failing. I say that guy is good, very good. He can solve a lot of big questions, but yeah, they be. So this is the formula for the kinetic energy total. So there's this question on the calculating the total kinetic energy. They said to find they said to find the kinetic energy trans, to find the kinetic energy the rotational kinetic energy, and if you find the total. So if this question is going to come out in MCQ, they'll just tell you to find the total. So yeah, I know that will find the rotational kinetic and the translational. So they said it's a cylinder. The question is in the description below this video, so it will be there. I'll upload there. There's a link there. Just download it from the link through the link. So they said it's a cylinder and it is falling. It is rolling downwards. It's rolling downwards, and they said the mass of that cylinder is 10 kilogram, and they get the velocity. So this is a linear velocity. How do I know? Because of this, and it's stated in the question that is giving it a speed. So this is meter per second. So it's linear velocity. If it were to be rad per second, that was angular velocity. So this is linear velocity. So to find the kinetic energy of trans, the kinetic energy of trans is half mv squared. So that will be half times the mass they gave us is 10 times velocity as 10 squared. Here I'll just give 5, and that'll be 500. What's our unit? 500 joule, because it's energy. So kinetic energy for rotational, that will be half I g w squared, right? Now, to get this, let's just, since we don't know the value for, they didn't give us the value for angular velocity, but we know that angular velocity, sorry, linear velocity is angular velocity times r. Can you see it? You cannot see it there. So you should know that linear velocity is angular velocity times r. You hope you remember this formula. So we are going to be applying this formula, and don't forget that this is a cylinder. So this cylinder, we are considering the cylinder to be, we are giving it the moment of inertia of the circle. That will be half, the stuff here is half ml square. That's the moment of inertia, half ml square, because we are not considering it as a rod, we are considering it as from this place, as I explained earlier. Yeah. So it's going like this. The central axis is like this. So that's half ml square times. Now from this formula, if you make the angular velocity subject of formula, can you see the board? Yeah, it will be v over r, right? So if the angular velocity is v over r, what is angular velocity square? If w is v over r, then w square will be v square over r square. Sorry, this is a circle, so it's not l square, it's r square. My bad. So w square will be v square over r square. You know, in the exam, we just not know how to quickly find your way back. So this r square is going to cancel this r square, right? This r square is going to cancel this r square. So when this r square cancels this r square, we are going to have half, then half mv square. That's if we are still returning back to our K trans. But here, since it's half, that's half times half will be 1 over 4. Half times half is a quarter. That's 1 over 4 mv squared. So let's just put in our values and get our answers. Should I write it above? Okay. Should I? Okay, so this will be 1 over 4. 1 over 4 times our mass is 10 times velocity is also 10. 10 squared. So let's say times 10 times 10. So the easy form is to calculate it. This is 2, maybe 5, then 5 will cancel this one again. So this will be 250 joules. So we got 250 joules for our KE rotational. So what's our total? The total kinetic energy. The total kinetic energy. Can you see the board? That side. Okay. Let me clean this part. So we already know for our trans is 500. Our trans is 500. Our rotational is 250. And what's our total? That one is the easiest. If you've gotten the two, now that one is just very easy. So if you've gotten for the two, you just know that the K total is the kinetic energy, the translational kinetic energy plus the rotational kinetic energy. And what we got for our transitional kinetic energy, we got it to be 500 joules. And rotational is 250 joules, right? 250 joules. So when you sum everything together, you just have 750 joules, and that's how you calculate your K total for that particular question.